All right, guys, so this is the last question I'm going to show for chapter 3 sapling homework. It's question 31, the arsenic in the lake question. All right, so let's read this. Suppose a group of volunteers is planning to build a park near a local lake. The lake is known to contain low levels of arsenic. Therefore, prior to starting construction, the group decides to measure the current levels of arsenic in the lake. Okay, so there's the backstory. So, if a 15.7 centimeter cubed, so that's a volume, sample of lake water is found to have 198.3 Ng, which is nanograms, so nano is 10 to the negative 9, of arsenic, what is the concentration of arsenic in the sample in parts per billion? So ppb, assume the density of lake water is 1 gram per centimeter cubed. All right, so this is a tricky question. There's actually two ways to do it, and I'll show both. So ppb can be defined in two different ways. It can be one ppb is equal to 1 nanogram of material over 1 gram. So if you report something in nanograms of solute over grams of your solution, that will be equal to a ppb. So solution, solute. So I'm using a mass and a mass on top and bottom. That's one way you can describe ppb as a concentration. Or since we're using water, and water is typically 1 gram per 1 centimeter cubed, or that's what the density is, or 1 gram per milliliter. That's the density of water. We can also report ppb in milligram. Sorry, no, that's ppm. Micrograms per liter of solution. So I will show you two ways to do this question. So the first way, we'll use this this first definition. So in this case, so I'll just put a 1 here. So 1 ppb will be equal to 1 nanogram of arsenic over 1 gram of our solution. So if we set up an equation where we have mass of arsenic in nanograms and the mass of the total solution in grams, then that'll spit out concentration in ppb. All right. So for the mass of the solution, they told us that the volume of the solution, the sample, was 15.7 centimeters cubed. So if we use the density that they gave us here, there's 1 gram of sample for every 1 centimeter cubed. So yeah, that's how that works. So you can convert the volume to a mass, essentially. So 1 centimeter cubed. So I'm just using the density, the derived units of the density. So 1 centimeter cubed is 1 gram of sample. So that means that that lake water sample weighs 15.7 grams. This is for our solution. Okay? So we have the bottom of our equation that we have, and the question tells us that they measured 178 nanograms of arsenic. So the mass of arsenic is already given in nanograms. Perfect. So the concentration will be equal to 178.3 nanograms of arsenic over the total mass of the sample, which is 15.7 grams of our sample. And that equals 11.4 nanograms per gram of sample, or 11.4 ppb of arsenic. I always like to say what it is, what the concentration is actually, what it's actually measuring. All right. So I told you there's another way to do this. So the second way I'm gonna show you uses this um, other definition of ppb for water samples, which is in micrograms per liter of solution. I feel like if you go out into industry, you're more likely to use this second definition. All right, so it's micrograms of solute per liter of solution, because most time with liquid samples you aren't measuring the mass of the sample, you're typically measuring the volume. So I'm just going to start with the equation, or the values that were given, which is 178.3 nanograms of arsenic over 15.7 centimeters cubed of the solution. So to get into ppb, I want to convert these values, the units, into micrograms per liter. So I'm pretty sure I can do that. So let's start with the bottom, the volume. So right now we're in centimeters cubed. I want to be in liters. So I know that 1 centimeter cubed is equal to 1 milliliter, and that 1,000 milliliters are in 1 liter. Whoops. I don't want to stick this into my calculator yet because I want to be in micrograms also up top. But right now we are in nanograms. So if you convert that, so nano is 10 to the negative 9 and micro is 10 to the negative 6. So this is typically how I do it. So nanograms is on top. So I like to think, okay, there's 1 times 10 to the 9 nanograms in 1 gram. And then in 1 gram, there is 1 times 10 to the 6th micrograms. Because I don't know how many nanograms are in 1 microgram. I feel like I would mess that conversion up, but I know how many nanograms are in a gram and then how many micrograms are in a gram, so I can just use that to get to the unit I want. So I don't have to memorize all these like in between units. All right, and so if we check our units, centimeters cancel, milliliters cancel, and we have a liter is left. Nanograms cancel, grams cancel, micrograms. So now, as is how this is written, it's in micrograms per liter. That is a ppb. So if you plug that into your calculator, sure enough, you get the same thing, 11.4 micrograms per liter. So 11.4 ppb. So those are 2 different ways to do it. Okay, so now the second part of the question. Yeah, so for the first part of the question, it was imperative that they gave us the density of the lake water. That was important. Here, we wouldn't be able to solve it without it. Okay, so the rest of the question, one of the volunteers suggests hiring an on-site water treatment company to remove arsenic from the lake. The company claims their process takes 2.33 days to remove 31.4 kilograms of arsenic from a water source. Oh, look, that's a conversion factor. So before I even go on, I'm just going to write, okay, 2.33 days is equal to 31.40 kilograms of arsenic removed. We'll probably use that. Okay. Calculate the total mass in kilograms of arsenic in the lake that the company will have to remove if the total volume of water in the lake is 0.65 kilometers cubed. Oh, wow. Okay. So they gave us volume of the lake, but we want mass of arsenic in kilograms. So if we use the concentration that we got before, so 11.4 ppb, we can use that to get from volume of the sample or volume of the solution, which is the volume of the lake, to get to mass of arsenic in the end. All right, because ppb, remember, means uh, nanograms of arsenic over what's it? Grams of our solution. All right. So how I'm going to set this up is figure out what the volume of the lake is in a better unit. I don't like kilometers cubed. I don't know how big that is. So let's try to get that into like centimeters cubed or something. So let's convert that first. So volume of the lake is equal to 0.650 kilometers cubed. I want to get it into centimeters cubed. So I know that in 1 kilometer, there is 1,000 meters. But because it's kilometer cubed, I actually have to cube this whole thing. So when you stick it into your calculator, you want to do times 1,000 caret 3. All right. So now we're in meters cubed. But I want to get this to centimeters cubed because remember, a centimeter cubed is the same as a milliliter. So in 1 meter, there is 100 centimeters. And then that all cubed. All right? So if you plug that into your calculator, you get that the volume of the lake is 6.50 times 10 to the positive 14 centimeters cubed. Great. So I want to start with this volume of the lake, so I'm just going to start a new line. I could have just kept going, but I just want to show you what my thought process is here. So, oops. So start with the volume of the lake times 10 to the 14 centimeters cubed. So our goal here is to get to grams of arsenic, and we're going to use the concentration given here. The concentration is 11.4 ppb nanograms of arsenic per 1 gram of sample. So right now, my sample is given in volume. I need to convert that to grams. I need to get from centimeters to grams. So this is where density of the water, lake water, comes into handy. That will convert us from volume to a mass of our solution. So if we use density given on that first part of the question, so for every 1 centimeter cubed, you have 1 gram of solution of our lake water. Great, now we can use ppb. So 1 gram of our solution is equal to 11.4 nanograms of arsenic. So this is our ppb. All right, the question asks what's the total mass in kilograms. But right now, if you see how our units cancel, we're in nanograms of arsenic. So let's convert that to kilograms. So again, I don't know what nanogram to kilogram is, but I do know what it is to grams. So I know that there's 1 times 10 to the 9 nanograms in 1 gram. And then there is 1,000 grams in 1 kilogram of arsenic. So plug that into your calculator, and then you get 7,410 kilograms of, I think it's 3 sig figs. Yeah, it's 3 sig figs. 3 sig figs of arsenic. So there's our answer. All right, and I forgot to write it down on my iPad, but I think the last question is how many years will it take to remove all of this arsenic? So that's where this red conversion factor comes from, that the company claims that their process takes 2.33 days to remove 31.40 grams of arsenic from a water source. So I would just start with how much arsenic needs to be removed. It's 7,400 kilograms of arsenic. And now use the conversion factor. 31.4 kilograms of arsenic can be removed in 2.33 days. Oh, but it wants it in years. So you can use the conversion factor for a year, 365 days. In 1 year, So I got 1.51 years, I believe. So that's actually pretty long. So that will definitely put a hamper on that project. So maybe they can find like a different company to take out all the arsenic. So, all right. So I hope that helps with this question. I'll just show my work if you didn't catch it again. So again, I showed you how to do this problem, the first part, two different ways using the different definitions of parts per billion for water samples. All right, so here we're using the nanograms per gram definition for ppb, and in the second way, we're using the micrograms per liter definition. So it can be done either way. And you get the same answer. And then for this part of the question, I use the nanograms per gram definition of ppb, but in your own time, you can use that second definition, and the dimensional analysis is just a little bit different, but it still works out. All right. And then my answer here is that's a ton of arsenic. All right. So I hope that helps, guys. Thanks for listening.